We're going to look at basic integration problems today. So what integration is? It's the opposite of taking the derivative. So they're going to give us the derivative. We're going to figure out what the equation is before we took the derivative. Okay, so if we look at a couple formulas, this little symbol right here, this like tall, skinny looking S, this is the integral symbol. Okay, this part right here is going to be some expression that's the derivative. So what's here is the derivative, and then there's always going to be a dx at the end of it. That just indicates that it's the derivative equation. Okay? So when we solve for it, what it's going to equal is the original function prior to taking the derivative. And then we always tack on a plus c, because when you take the derivative of a constant, it's 0. Okay? So whatever the constant was in the original function, it's going to disappear when we take the derivative. Okay. So our power rule, so if we have x to some power, okay, and whatever the coefficient is, to do the antiderivative, okay, this is the little formula for it. It looks more complicated than it is. Okay, so what we do is add 1 to the exponent and divide the coefficient by that new exponent. Okay, so what this means right here is add 1 to the exponent, and then you're going to divide the coefficient by the new exponent. So this formula actually makes it look a way more complicated than it is. So let's look at a couple examples. For number 1, okay, so this means we're taking the derivative. So what we're going to do is find the general solution to each differential solution. So what a differential solution is it's just the derivative. So they're just saying this right here is the derivative. So anytime you see this integral symbol, that means take the antiderivative. Okay, so what's right here? This is f prime. Okay, and this dx, it doesn't do anything with our work. It just indicates that this is the derivative. So to take the antiderivative, so that's just finding regular f of x. I'm going to add 1 to this exponent. So if you add 1, that makes the new exponent 4. You're going to take the coefficient that's there, divide it by the new exponent. Okay. Then I'm going to take this next term, this is x to the first. I'm going to add 1 to the exponent. So I'm going to leave the coefficient, that'll make it x squared, and then I'm going to take this 4, divide it by the new exponent that I just got. Okay. Then when there's just a number, to take the antiderivative, you just tack on an x to it. Okay, because what that is, this is like x to the 0. So when you add 1 to the new exponent, it just becomes x to the first. You would divide the 1 by 1. It's still going to be 1. So anytime you have just a regular constant, you just tack an x on with that constant. Okay, and then at the end of everything, you're always going to put a plus c. Okay, because there could be any constant here. Okay, because when we take the derivative of it, it's just going to go away. And then when you simplify this, I can't simplify 9/4, so I'm just going to leave that as 9/4 x to the 4th. But I can reduce the 2 over 4. That'll just be minus 2x squared plus x plus c. And this right here would be the general solution to this equation. Okay. If you wanted to check your answer, you could just take this and take the derivative of it. So the derivative is when you move the exponent in front and multiply. So 9/4 times 4, that would give us 9x cubed, which matches that first term. Then move the 2 in front. So 2 times 2 would give me minus 4x to the first. And then the derivative of just a plain old x would be 1. Okay. And then whatever constant this is, it just goes away when I take the derivative. Okay. So once you integrate something, which is taking the antiderivative, okay, you can always take the derivative of your answer. It should match the original if you want to check your answer. Now, if we look at number 2, okay, this one's written a little differently. It says dy over dx equals negative 2x to the 5th minus 6x plus 3. Okay, this is just another way of saying take the antiderivative, which is integrate it. Okay, so instead of writing it like this, they've just said dy dx equals. Okay, so we're still going to integrate this. Remember, this little symbol means take the derivative, antiderivative. So to take the derivative of this one, so I'm just going to put y equals, since this is dy dx, our regular, so this is like y prime. So this will be y equals, I'm going to add 1 to this exponent, so that'll make it x to the 6th. So that's going to be negative 2 over 6. You always divide by the new exponent, x to the 6th, and you can divide and reduce all in the same step. I'm going to wait till the next step. Okay. Then here the exponent's 1, so I'm going to add a 1. That'll make it x squared. So I'm going to do 6 divided by 2, x squared. And then anytime it's just a number, you tack an x on with it when you're doing the antiderivative. Okay. And then put a plus c because there could be any constant here at the end. And then go ahead and reduce the coefficients you can. So that'll be negative 1/3 x to the 6th minus 3x squared plus 3x plus whatever constant we have at the end. Again, if you want to check your answer, just take the derivative of this. It's going to match the original differential equation they gave us. Now let's look at some that maybe aren't as simple. So these are ones where we have x's in the denominator. We cannot take the derivative of something when we have an x in the denominator. Same thing when we're doing the antiderivative. Okay, so before we integrate this, okay, and integrate and take an antiderivative are the same thing. I need to rewrite it without this x on the bottom. So you're just going to leave the coefficient, you're going to move the x up and make the exponent negative. Okay. And then again, this dx, it doesn't do anything. It just means that this part right here, it just means this is the derivative. So to integrate it, add 1 to the exponent. So our regular equation here is going to be f of x equals 9 divided by, that new exponent is going to be 3. So this will be 9x cubed, 9/3 times x cubed, minus here when I add 1, okay, negative 2 plus 1 is negative 1. So this will be minus 1 divided by negative 1, x to the negative 1, plus c. And then I'm going to reduce my coefficients. So 9 over 3 is 3. This is negative 1 divided by 1, which is going to be positive 1. So this is 1x to the negative 1. So I'm also going to take the x and move it down to the bottom. Okay, so in your final answer, you don't want any negative exponents. And then I still have plus c. Okay, and c is just any constant. Now for number 6, okay, again, there's a fraction with an x on the bottom. So we have to rewrite this. So I'm going to move the x up and make it x to the negative 2 plus 5. Then we're ready to integrate it. Okay, so my regular equation is going to be f of x equals, and you could put y equals if you would rather put y equals. So this is x to the first. So I'm going to add 1. So that's going to be 3 divided by, my new exponent is going to be 2. So that'll be 3x squared. Then minus here, when I add 1, negative 2 plus 1 is negative 1. So this is going to be minus 2 over negative 1, x to the negative 1. And then when I have a constant, you just tack an x onto it when you're doing the antiderivative. And then your very last step is to put a plus c. I'm going to simplify this one right here. Nothing else can be simplified in this problem. So this will be 3/2 x squared, negative 2 divided by negative 1. That's going to become positive 2. The x has a negative exponent, so I'm going to move it to the bottom and make it x to the positive 1. So I don't need to write that exponent. And then plus 5x plus c. Now let's take a look at some of the trig derivatives. So with these trig derivatives, we're just, again, going backwards. So if we're trying to integrate cosine, the antiderivative of that is sine. Sine will turn into negative cosine. If we're integrating secant squared, that's going to turn into tangent, okay, and so on. Okay, and the reason is, if you remember back from first semester when we were trying to take the derivative of tangent, the derivative of tangent is secant squared. And now we're just going backwards. So let's look at a couple questions with trig in it. So for 7, we're integrating 2 sine of x plus 3 cosecant of x, cotangent of x, dx. So we're just going to go term by term to get f of x. So what I'm going to look for on my integrals, okay, I'm going to look for what the antiderivative of sine is. So if we jump back here, the antiderivative of sine turns into negative cosine. So since there's already a coefficient here, the coefficient's going to stay, and this is just going to turn into negative 2 cosine of x. Then I'm going to look at this term next. Okay, so I'm looking for, on that integral sheet, I'm looking for cosecant, cotangent. Okay, so here's where I see cosecant, cotangent. That turns into negative cosecant. So this part right here, since there's already a 3 in front, I'm going to leave it, and it's going to turn into a negative 3 cotangent of x. And then I'm going to tack on my plus c still. Okay, and I wrote this part down wrong. This part needs to be negative 3 cosecant of x. Because when I jump back here, antiderivative of cosecant cotangent is negative cosecant of x. Now let's look at this last one. Okay, so this is just kind of a mix of everything. So before we integrate it, we need to rewrite it without an x on the bottom. So we've got 3x squared, 3x to the 5th minus 4 cosecant squared of x, and then move the x up and make it minus 3x to the negative 4. And then we're ready to integrate it. So add 1 to this exponent. That's going to make it x to the 6. So this will be 3 over 6 x to the 6, remember whatever the new exponent is, that's always what you're dividing by. Okay. For the trig ones, you're looking for the antiderivative, that's what the integral means, of cosecant squared. So here's where I've got the antiderivative of cosecant squared. That's going to turn into negative cotangent, so that just means we're switching the sign. So this will now become plus 4, since it's already minus 4 cotangent of x. And then on this last one, we're going to add 1, so negative 4 plus 1 makes the new exponent negative 3. So I'm going to have minus 3 divided by negative 3, x to the negative 3, and then we're always going to tack on a plus c. And then we're just going to reduce what we can and get rid of any negative exponents by moving them back to the bottom. So this will be 1/2 x to the 6 plus 4 cotangent of x, negative 3 divided by negative 3, that's going to be positive 1, and then I'm going to move the x to the bottom, so that'll now be 1 over x cubed plus c.